And we're here, okay? Now, this is correlation, the correlation coefficient. So I just went here to the calculator. Don't do this, just look at this. And I had stat edit. I had some data here, which was a question from chapter 1 in the AB textbook. So the data doesn't matter. It's just doing this. Second quit, stat, calc, linear regression, which is for second 1, second 2, where the data is, calculate, and you get this R value. Well, that's what we're going to show you how to calculate. Like, you got it when you were in Algebra 2, but you weren't responsible for doing this. So we're going to show you where the calculation comes from. And that value squared is R squared. Now, you got to be careful because you may not see this. If I go here, second catalog, right? And I go to, I'm in alpha mode. So I'm going to go down here. You don't do this, just look up here. And I might not see that because earlier this morning, mine was off. So I didn't get the R and R squared. So if you're doing this and you don't get those values, it's because your diagnostic is off. And the way to turn it on is to go to second catalog. And when you do that, this alpha key up here means you're already in alpha mode. You don't have to push the green key. So I just type D, scroll down to get the diagnostic on, and then you will see the R values, okay? So this is, you never saw this in Algebra 2. This is what R is. You couldn't do it because you know what a standardized score was. So these are z-scores. See, this makes sense to you. You have these entries. You have these ordered pairs. So we have 0.1. The x-coordinate of 0.1, take away the x-mean, divided by the standard deviation of the x's. That's the z-score, the standardized score for this 1 point. And you do the same thing for the y-coordinate. How far it is from the y-mean divided by the standard deviation of the y's, and you multiply them. And you add up all of those products for each point, and you divide by n, take away 1. All ready? We did that before. We did that for standard deviation. We divide by 1 less than the number of terms. We will quantify for that for you later. We're not there yet. Why don't you divide by n? So in your textbook, they give you this. You get a formula sheet on the AP test. It is in the resources folder for Canvas. It says College Board Formula Sheet. They're giving you this. But in reality, here's all you're doing. The R value means the average. We're dividing by n, take away 1. The average product of the z-scores. So add them up. Each one of these, that's the z-score for the x value, the z-score for the y value. For what? For the explanatory variable, for the response variable. Multiply them together. This sigma is add them all up, divide by n, take away 1. That's what R is. So we're going to show you one, walk through. You're not going to do it. I'm just going to show it to you. Okay? So you used correlation before you knew where it came from, is the point. So you're going to go to this data set, which is about hot dogs. right? Number 19 is about hot dogs. So you're doing problem 19 and 23. They go together about hot dogs. And 21 is a problem about R value that I will walk through with you. Okay? So we're going to pause the video. Hopefully I remember to restart it. Okay, so we're going to go over 19. They gave you this picture. Now what's happening? The input is calories and the output is sodium. So the input, calories are the explanatory variable and salt content is the response variable. They're telling you that the R value is 0.87, which means what? That the average of the product of the z-scores is 0.87. So how's my reply to that? Linear, strong, and positive. The shape is linear. It is strong, and the trend is positive. Now you got this one hot dog down here. Looks like one of those mini hot dogs they sell, like wrapped in the. I mean, I don't know how this hot dog has only that many calories in that. It's a diet hot dog. Okay, 108 calories, 145 milligrams of salt. What does that do to the correlation? It increased the correlation because this is going to be close to the line of best fit. If it's close to the line of best fit, it makes the R value go up. If it's away from that, it wouldn't. I really wouldn't worry about B so much. I would go to 23, and they say this. It's not correct to say that the R value is 0.87 milligrams per calorie. There's no units. Ready? It's the product of the z-scores. There are no units in z-scores, standardized scores. What would happen if you reversed on the scatter plot and you made calories dependent upon salt content? Wouldn't matter, because you're still multiplying the z-scores. So what you're doing in here is you're multiplying this, you're multiplying from right to left instead of left to right. Doesn't matter. And how about if you measured in kilograms instead of grams? No effect. It's based on standardized scores. Okay? Now, this isn't on there on Wednesday, because this is bivariate data, 2 lists to build that scatter plot. Your assessment's on univariate data, 1 list. So we're going to do one more thing, which is for you to go to page 173 and just read question 21. Just read it. I'm going to walk you through the solution. Okay, so on the PDF, I drew a scatter plot of the data. Okay? And we're going to calculate the R value the long way. Now, is this on the test? Is this on the AP test? Right? That is a college prep honors question. Is it on the test? This goes to your depth of understanding. For you to maximize your score in May, you have to have a depth of understanding. You don't need to reproduce this, you need to follow it. So here's the data set. Do you understand what happened here? I went to the calculator and found the mean of the input. So the explanatory variable here is your femur. There's the mean value. And all we're going to do is go over the left column because the right column is the same thing. Just with the output, which was the humerus bone. Okay? So I want to find out the sum of how far each entry in this list, list 1, is from the mean. And I want to divide it by 4 because there's 5 entries there. Now for each one is, square it, divide by 4. I get this value. I take the square root. That gives me the standard deviation of the explanatory variable. Over here is the standard deviation of the response variable. Now I go to list 3. And in list 3, I say, how far is each element from the mean, which we calculated to be 58.2. Divide it by A, which was where we stored the standard deviation. Same thing over here in list 4, divide it by B, which is the standard deviation for the humerus. So list 3 and list 4 are full of z-scores. They're standardized scores. So if I look at the first entry, which is 3841, 3841 has a negative z-score for each bone. It's lower than the mean. Okay? I'm going to go to list 5 and multiply these two lists across. It's the product of the z-scores. Add them up. Divide by 4, because there's 5 entries in the list. And remember, we will quantify that for you while you're divided by n take away 1. And you get this value. Well, then I just did what you do in Algebra 2. I did linear regression, right? Except this looks a little different because it's backwards. We'll show you that. A plus bx. It's the same numbers. There's my R value. This R value instantly on the calculator corresponds to the R value we did the long way. So you're not going to have to do it the long way, but you should follow what happened. So if I'm describing this data, this scatter plot, I would say it is strong, which I can tell later because I know the R value is over 0.99. It's linear and it's positive because it's going up from left to right. Okay? So